Good afternoon. It's March 25th, 2020. My name is Val Zudans. I'm an ophthalmologist who's practicing in Vero Beach, Florida. I gave a talk about 5 days ago on March 20th about coronavirus. In particular, I talked about what you as an individual have the power to control in a situation like an epidemic like this. I did my best to try and explain why our leaders in the government and healthcare are making the recommendations that they are, and the things that you can do in particular to avoid infection, and then if you do get infected, what to do to survive the infection, what to do to improve your immune system ahead of time, and so forth. And if you're interested in watching that video, I did get some feedback from several people letting me know that they found it very helpful and reassuring, and I'd encourage you to go ahead and watch that video. It's available on YouTube on my channel, Zudans, Z-U-D-A-N-S. In that video, I talked about the two components, the R0 and lethality in epidemics. R0 is the average number of, it's the average number of people who get infected, by each individual who is infected, how many additional people they infect. And if you can get that number below 1, then an epidemic will die off. And when you're above 1, you're going to be expanding in the number of people infected. And the social distancing is one of the primary, and hand washing are the primary ways that we avoid or reduce the R0. Today I'm going to talk about lethality, the second part of that, and also how treatments can both decrease the R0 as well as lethality of viruses. And before I get into any of that, I just want to give the same disclaimer I did last time, which is I'm not your doctor. You should not be taking medical advice from me. This is for your information so that you are better informed and you know what questions or how to ask your doctors, or why the things that are being recommended by our leaders are being recommended. The interesting thing, and I'm going to talk today specifically about the study, the very small study that was done in France, why they did the study, what the outcomes were, and why we should have further hope based on this, that we can both decrease the R0 as well as lethality of this disease, and also give some caveats on some reservations we should have on that study and some potential side effects of those treatments. There are multiple simultaneous tracks going on at the same time. I'm only going to be talking about one aspect of this. Everything that has been said before should still be followed. Specifically the social distancing, the hand washing. I'll talk about antiviral treatments. The government is working frantically to build the critical care infrastructure. And if we're able to slow down this disease and slow down the presentation of the disease, we may and should be able to have enough critical care capacity to take care of the people who do get this, particularly the very small fraction who need those critical care resources. I'd primarily like to discuss the study published March 17th, just a week ago, by Guatret. I probably pronounced it wrong and I apologize, Gautret, that's all. It was out of France, and the title of the study was Hydroxychloroquine and azithromycin as a treatment of COVID-19, results of an open label, non-randomized clinical trial, published in the International Journal of Antimicrobial Agents. Before I get into the study, I want to just review why they thought that one or both of these, or the combination together, may have been beneficial. And it started with reports out of China and South Korea, where they had used some of these drugs, or particularly the chloroquine and hydroxychloroquine, which is a safer related antimicrobial. And they had reported that they had shortened viral loads and improved respiratory responses. In China, they were using mostly chloroquine, which was 500 milligrams twice a day. Extremely inexpensive and readily available there. In South Korea, they were using hydroxychloroquine, which is a safer derivative of chloroquine, a little bit more expensive, but that was what was available in South Korea. We do have FDA-approved hydroxychloroquine in the United States, which is brand name Plaquenil, and one of the reasons why they thought this may have been a good option is because in vitro, in the lab, the Plaquenil is effective against SARS-CoV-2. SARS-CoV-2 is the virus that causes the COVID-19 infection, and it's kind of like HIV versus AIDS. HIV is the virus and AIDS is the clinical disease. So in addition to being the hydroxychloroquine in the lab, in vitro, is more effective than chloroquine against the SARS-CoV-2 virus, and is also tolerated in higher doses, which allows you to get above the level where you'll have effectiveness, and also has fewer drug-drug interactions. As an ophthalmologist, I follow a lot of patients who are on Plaquenil for other reasons. It's a very effective long-term immune suppressant for patients who have autoimmune conditions. And in the past they had used chloroquine before hydroxychloroquine was invented, and there were definitely more retinal toxicity, retinal disease related to long-term use of chloroquine. Since they've switched over to hydroxychloroquine, those have decreased significantly. And it's actually quite rare nowadays to have to stop someone's Plaquenil, even with years and years of use, due to ocular side effects, although we still monitor. So before we get into this study, the mechanisms of action, hydroxychloroquine, chloroquine, and quinine, which was the original alkaloid, in all three of them basically we believe work in the same mechanism. What they do is the alkaloid increases the pH inside of lysosomes, which are subcells within cells. And the virus and other organisms are likely using these lysosomes in order to replicate or transfer the viruses from one cell to another. And so by changing the pH within those lysosomes, it can interfere in those pathways, and has even been shown across multiple different microorganisms. There's even some reports of in vitro, in the lab, effectiveness against HIV, malaria, coronavirus, and others. Azithromycin, which is also discussed in this study, commonly used as a Z-Pak, has been an antimicrobial mainstay for bacterial infections for years and years. When you have a bacterial infection, it's not unusual for your doctor to prescribe a Z-Pak, which is it's very convenient because it's just 5 days of treatment, 2 pills on the first day and 1 pill each day for 4 days. The interesting thing with the mechanism of action for azithromycin, it's a macrolide similar to erythromycin, and it binds to ribosomes, particularly when it's fighting bacterial, the bacterial ribosomes. Ribosomes translate mitochondrial or messenger RNA into proteins. And by interfering with this process, it can block protein synthesis. So viruses don't have the ability to do a lot of things they need to do to replicate. So they utilize our own cells they basically hijack our cells in order to replicate their virus and pass it on to another cell. So interestingly, the azithromycin also has effects against bacteria, which we knew about, but it also is effective against some viruses because it can interfere in their pathways as well. So in the past, azithromycin has been shown, at least in the lab, to have some effectiveness against Ebola viruses and Zika viruses that have made the news recently. As well as some of the people who are dying related to this current epidemic are not dying from the actual virus, but from secondary infections. So there's a side benefit to the combination of this, a theoretical side benefit that it may also help to prevent what are called super infections or secondary infections, where you get a bacterial infection on top of your viral infection. So One of the key things with going back to R naught, the number of people that each individual is passing the virus on to, one of the most important aspects of whether or not you're going to transmit this to other people is how long are you shedding the virus. And the reports out of China are significant in that the reported average of viral shedding was 20 days. So that you had a very long period of time that if you interacted with someone, you could potentially spread the virus. And there were some reports of up to 37 days of viral shedding. In this study, and that's significant, and I'll talk to you, the main outcome of this particular study that was done in France was to see how long it took, or whether they could reduce the viral shedding in order to reduce the R naught. In this study, these were patients who had PCR. PCR is a genetic test to see whether or not the SARS virus, SARS-CoV-2, was present. So in order to be included in the French study, you had to have a PCR confirmed SARS-2. And the primary endpoint was undetected viral load on the PCR test. So you had to start out with the virus proven, and then you had to show that you could not detect the virus anymore. So they had 26 patients who were treated with hydroxychloroquine. 6 of those 20 were lost to follow-up. And of particular concern, one of those who was lost to follow-up later died. That means they were withdrawn from the study. They were no longer getting the antivirals, the hydroxychloroquine, and so it's unclear whether it was in any way related to the withdrawal of the hydroxychloroquine or what happened to that patient, but they eventually went to an ICU and they did pass away. They were not included in the results because they did not continue to have the test, and there were others who, for a variety of reasons, also were withdrawn from the study, one due to some nausea side effects, and some others who declined to continue to participate. Interestingly, the patient who did die on day 2 had after a positive antiviral, a positive PCR on the initial day. On day 2, actually, before they were withdrawn from the study, showed a negative result on the viral test. But it's unclear whether they would have been better off continuing to take the antiviral or whether the virus recovered. It is possible that the levels of virus got so low that they were no longer detectable, but then by stopping the antivirals, they may have come back. We can't really draw any conclusions based on a patient who was withdrawn from the study. The groups were it does sound from reading the study, there were also, in addition to the 26 people who were initially enrolled and 20 who were followed through the completion of the study, there were also 16 controls. The controls were people who, for some reason, were not allowed to be in the study, pregnant or nursing, allergies, a cardiac arrhythmia that prevents you from being in the study. There were a couple of reasons, but in general, the two groups, if anything, the treatment group appeared to be sicker than the non-treatment group. Some of the people who declined, basically, if you were not enrolled in the treatment arm, you could be in the control group. And so some of those were people who were less sick, who decided they didn't really want to take an experimental treatment, and so they were in the control group. But in general, people who were in the treatment group were significantly older and potentially less healthy than the people who were the control group. Despite that, the treatment group, as far as the outcome of viral load, was statistically significantly quite different. And so what they looked at, the primary endpoint was at 6 days, and they wanted to see what percent of the people who were positive for virus at the beginning were undetectable viral loads at 6 days. The group that got the Plaquenil, the hydroxychloroquine, 70% of them were PCR negative for the virus at day 6. In the control group, 12.5% were PCR negative. The statistical significance of that, the p-value, is less than 0.001. That means that there's less than a 1 in 1,000 chance that that's purely random. Even quicker than day 6, at day 3, 50% of the patients who were getting the Plaquenil were negative on their PCR, and only 6% of the controls were negative on their PCR for the virus. And as we said before, people who are not shedding virus, we don't believe, can be spreading the virus to other people. So that alone theoretically would have a huge impact on the R naught spreading from patient to patient. In addition to, out of the 20 people in the treatment arm, just 6 of them got azithromycin as well. Okay, and that was based on clinical presentation. They all had respiratory infections, so the doctors were concerned. Basically, if they had any concern that the patient may be getting a pneumonia or some type of secondary bacterial infection, they added in azithromycin. The 6 people who got both Plaquenil and azithromycin, by day 3, only 1 of the 6 had a positive viral load at day 3. And by day 5, 100% were PCR negative for the viral load. And what that suggests is that the azithromycin, in addition to the hydroxychloroquine or chloroquine, is not just for the super infections. It's probably alone, and maybe even more so in combination, having an effect on the viral load. At least that's my interpretation of that. There were some people who were excluded for something specific that I wanted to talk about, and that is a cardiac arrhythmia that can come with, has been shown in both chloroquine as well as azithromycin, and that is what's called a QT prolongation. QT is part of the echocardiogram, electrocardiogram signal that you have for your heart. And if you, what some drugs do is they can cause an arrhythmia that's related to delayed repolarization. So you have electrical signals running through your heart that tell your heart to contract, and then the electrical signal has to reset. Some drugs can slow down that resetting. Both azithromycin and chloroquine have been shown to have that potential side effect, and it's not clear what happens if you're using them together and what potential drug interactions you should find. And it's also not clear whether the hydroxychloroquine is less likely to cause that particular interaction than chloroquine, although theoretically it should be. So in particular, if people have a cardiac arrhythmia, particularly one that prolongs that, or on other known drugs that could interfere, then we definitely need to take that into account, or their doctor needs to take that into account when they're considering these drugs. But overall, in my mind, it's clear that there's something very dramatic happening with both the hydroxychloroquine as well as combination with azithromycin that appears to dramatically shorten the amount of time that you're releasing virus, as well as reports that it reduces the underlying symptoms. And unfortunately, the size of the study is very small, and there were some issues with people, a significant number of people withdrawing from the study before it was completed and not knowing what to make of those particular cases. And we will see, because this is being used widely at this point in New York and other places, and we will have much better follow-up once we have a larger group of people taking this. But it, to me, sounds incredibly promising that it will help us turn the corner and end this a lot sooner than what we were thinking. I appreciate your feedback and comments, and I hope that this was helpful to you as well. And if you have particular other topics you'd like me to talk about, I'd be glad to do so. Just let me know, or post on the YouTube, or I'm also on Twitter, Fly Guy, FLEYEGUY, Fly Guy, so I'm Florida I Guy. And hope you have a great day and stay safe, and follow all the instructions, and listen to your doctor, whatever they say. And my prayers also are still going out to everybody. I hope that everyone makes us through this great, and I hope that you feel better and have a better understanding of what you can and can't do in this situation. Hope you have a great day.